Hi, I'm Josh Bloom. Welcome to another video in the RSP Supply Education Series. Today we're going to be talking about the different signal types. Signals come in many different forms. Those forms can depend on the data that's being communicated, the type of measuring device that's being used, or the limitations of the hardware. While there are many different things that can determine the different signals, we will primarily focus on some of the more common signal types. More specifically, analog versus digital, and also inputs and outputs. Let's start with digital signals. As far as digital signals are concerned, they are represented in either a true or false. There is no gray area with digital signals. An example of this might be a light switch. A light switch is either on or off. Other examples of this might be a motor that is running or not running, or something that is open or closed, or something that is occupied or unoccupied. Computers are also built off this type of logic, seeing only either zeros or ones. Digital signals can be generated with both AC and DC circuits with varying voltages, currents, and resistance. Some practical examples of using digital signals in an industrial environment might be if a pump is running or not running, or a valve that is either open or closed, or we might want to monitor if a door is open or closed for security purposes. So these are just a few of the different type of examples where we use digital signals. Now let's move to analog signals. Analog signals convey information a little differently in the form of a range. While we might still see zeros and ones, we also might see something in between like 1.5 or 1.1 or 1.2. When we think about the light switch being on or off as a digital signal, you could think of an analog signal as a dimmer switch. We can be on or off, but we can also be somewhere in between. Now let's look at some examples where we might use analog signals in industrial applications. For example, we might want to measure the level of a tank, whether it's full or empty or somewhere in between. Or we may need to monitor the flow in a pipe. How fast is that water moving? We also might need to monitor the temperature in a room or in a plant, or the temperature of water or another type of fluid. Analog signals can take many different forms. Some of the more common are a 4 to 20 milliamp signal, or a 0 to 5 or 0 to 10 volt signal, or there are many other voltage or amperage variations with analog signals. Due to interference and noise, which can affect significantly long runs of wire, we want to make sure with analog signals that we use a twisted and shielded pair. This will help us reduce that interference and noise with analog signals. In comparison with analog signals, digital signals are much easier to sense and create, therefore the hardware related to these types of signals is significantly reduced. Communication in a device can either be sent or received. Whether that data is sent or received is depending on the type of information. Do we need to monitor the status of something? If so, we need to receive an input about that information. Do we need to control something? If so, we need to send an output about what we want to occur. Receiving inputs and sending outputs are both things that can be accomplished by using both digital and analog signal types. So in this case, we start referencing signals as analog outputs, or AO, also analog inputs as AI, or digital inputs as DI, or digital outputs as DO. So let's remember, digital signals are either on or off, like a light switch. Analog signals measure a range of values, anywhere from on to off and anywhere in between, kind of like a dimmer switch. For a full line of products related to analog and digital signals, or thousands of other products, please go to our website. For more information or other educational videos, go to rspsupply.com, the internet's top source for industrial hardware. Also, don't forget, like and subscribe.